Welcome all. Today we are going to study the theorem 6.1 basic proportionality theorem. So this is the theorem. The theorem states if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Let's split the statement first. So for example, if a line is drawn parallel to one side of a triangle. So I am going to make one partition here and then here and here. What it says in the first statement, if a line is drawn parallel to one side of a triangle. Let me draw one triangle first. I name them as A, B, C. So what is the second statement says? To intersect the other two sides in distinct points. So first I am going to draw one line which is parallel to one side of a triangle. This intersect the other two sides. So what are the other two sides? AB and AC. This line is parallel to BC and the other two sides are AB and AC. So it says it intersect the other two sides in a distinct point. So I am going to name them the point as DE. So this is D, this is E. So we need to prove the other two sides are divided in the same ratio, which means AD upon DB equal AE upon EC. This is what we are going to prove here. Let's start. So whenever you try to prove one theorem, you always start with the given, and if any construction is there, you write it under the construction, then start proof. So here what is given? If a line is drawn parallel to one side of a triangle, which means we know that DE is parallel to BC. This is what given. So what we have to write in construction? So here I am going to do one small construction in order to prove this. Since we have only this triangle, right? Only this triangle we have ADE. So to make more triangle, I am going to join DC and EB. Now we have more than one triangle, BDE and DEC, like that. So what need to write under the construction? Join DC and BE. So first I am going to prove the LHS side, which is AD upon DB. To prove this, I am going to use the formula of area. To start this, I am going to take these two triangles ADE and DBE. Why? Because we have AD and DB. These two base is present in these two triangles only. ADE we have AD and in DBE we have DB. So I am going to find the area of ADE then DBE. So what is the formula of area of triangle? Half into base into height. So I am representing the area as AR. So area of triangle ADE equal half into, so here base, here look at the picture. Here we have AD, DE and AE. Three different sides we have. So which one will be benefit to me? AD. So here I know I am going to prove first AD upon DB. So if I take AD, it will be easy to prove this part. So I'm going to take the base as AD as base, and the height, to measure the height, I'm going to draw one perpendicular line which is opposite of AD, the base. The opposite side is E. So I'm going to draw one line, perpendicular line from the opposite sides of base to the AD and name the point as N. So this is perpendicular line, this is the height of this triangle. So height is EN. Next I am going to take the triangle DBE in order to prove this one DB. We have DB in this triangle, right? Okay, let's start. So area of triangle BDE, half into base. Here we have base as, here the best base which is benefited to me is DB, right? So DB, I am going to take DB as base. So here half into for base DB or BD, anything. For height, to measure this height, I drew the DBE, PDE triangle separately, and look at here, the BD line is extend to AE. Okay, here is A and here is N, here is E. So we can take EN as height for this triangle also, because DB is in AD line, both are in the same line. So EN is the height for this triangle also. Next step, I am going to divide area of ADE and area of BDE, which is half AD into EN divide by half DB into EN. So we can cancel EN and half half. The remaining is AD upon DB. Let's assume this as first equation. Let's try to prove this part. Okay, AE upon EC. So AE upon EC, or the base of these two triangles ADE and DEC. So let's find out the area of these two triangles and follow the same step. So area of ADE equal half into, for base I am going to take this time AE is the base. In this triangle previously AD is a base, this time AE is base, since we need to prove AE upon EC. Then what will be the height? So again I am going to draw one perpendicular line from the opposite sides of the base. Here base is AE, the opposite sides of AE is D, right? And I am going to name this as M. So in this triangle base is AE and height is DM. Okay, next in the area of DEC. So here base is EC, height is DM, because EC is extend to A. So AE and EC both are in the same line. So both has the same height. So here base is EC, height is DM. Let's divide these two. Area of ADE and area of DEC equal. Next step we can cancel half half and remaining is AE upon EC. Assume this as a second equation. Then in the next step, how to equate these two to prove this? So look at the pictures again. The triangle DBE or BDE and the triangle DEC. So these two triangles shares the same base, which is DE, right? And same time DE is parallel to BC. So we can say the area of both triangles are equal. So area of BDE equal area of triangle DEC. So now we can substitute for BDE, we can substitute DEC, okay? Remember this. Let's move to our equations. So here is the first equation. So look at the LHS side. Here area of ADE. Look at the second equations, area of ADE. Look at the denominator. Here we have area of BDE. Here we have DEC. Since these two area is same, we can substitute for this area of BDE. Both are same, right? We just found out. Since the one side of the equation is similar, then the other sides also equal. So AD upon DB equal AE upon EC. Hence proved. Not only this proof, there are still more proof can be proved. For example, the reverse of this. So dE upon, reverse means the reciprocal of this, dE upon AD equal EC upon AE, also true. Apart from this, again we can prove if you add 1 on both sides, so what will happen? So AD, DE plus AD equal EC plus AE. Let me do it in the next page. Sorry, this is AD by DB, okay? Sorry for that. So AD upon DB. So this is what our proof, right? So what I told, the reverse, the reciprocal of this also true, which means BD upon AD equal EC upon AE. This is also true. If you add 1 on both sides, one, so AD is the common denominator, take LCM. So BD plus AD equal EC, so here AE is the common denominator, so EC plus AE. If you look at the picture, BD plus AD equal AB, okay? So AB upon AD equal, for EC plus AE, so look at here, CE plus AE, AC, the whole part. So let me write AC upon AE. So this is also proof, and same time the reciprocal of this one, AD upon AB equal AE upon AC. So this is also true. So this part doesn't come under proof, but this will help you solving many problems related theorem, and same time it will be used to prove some other similarity criteria theorem also, which we will discuss later. Hope you understand. Thank you.